Good afternoon, everyone. Welcome to EISCP webinar series. So EISCP at Indian Institute of Science is conducting e-workshop on Environmental Day and focusing on the exclusively urban and water issues. So today we have with us Dr. Vinay from Alvas Institution, and also we have with us Dr. Chandan MC from NIE Mysore. So this e-workshop is mainly aiming to create awareness in regarding World Environment Day. So World Environment Day will be celebrated every year on June 5th to continue the tradition established by the United Nations in the year 1974 to encourage worldwide awareness and action against protecting the environment. So World Environment Day aims to inspire and mobilize the people worldwide to act against pollution and promote a cleaner and healthier planet for future generation. In this regard, this year there is a theme on land restoration and desertification and drought resilience is proposed. So which mainly focusing on how we can protect our environment and also avoid the desertification by maintaining the clean and greener planet to also face the climate issues. So we will celebrate Environmental Day to demonstrate and support the environmental protection. So as an individual, it is our right and also responsibility to protect our environment. So in this regard, today we are having two experts. One is Dr. Vinay from Alvas Institution. So he did his postdoctoral research at IIT Kharagpur and also did PhD from VTU Belgaum. And he has published extensively in national as well as international peer-reviewed journals, around 25 articles. He has published 5 book chapters, 33 conference proceedings, and also 50 technical reports in association with Indian Institute of Science. His area of research includes application of GIS and remote sensing, focusing on forest, land use, as well as modeling, including data mining. So his research also focus on climate change, hydrology, and environmental management issues. So he has been awarded as Sahyadri Ecologist in the year 2016 and also Sahyadri Young Ecologist in the year 2014. And he has received Sir M. Visvesvaraya Best Project Award during his BE and also received a Best Paper Award during 2017, 2018, awarded by NSRS as well as WEAZ at IIT Kharagpur. So along with us, Dr. Chandan, who is currently Assistant Professor at the Department of Civil Engineering from the National Institute of Engineering, Mysore. So he did his doctoral research at Indian Institute of Technology, Kharagpur. He has contributed extensively for the urban domain, and he has published 10 peer-reviewed international publications and also 5 peer-reviewed book chapters, 25 papers in international conferences, and 8 papers presented at national conference. His research interest includes urbanization, urban sprawl analysis using geospatial techniques, and also urban sustainability transitions and modeling, and artificial intelligence and machine learning applications to the land use modeling. So these two experts will provide a brief overview about the issues associated with respect to the urban as well as hydrology in a particular landscape. So now I request Dr. Vinay to share his views on hydrology. So Dr. Vinay will speak on land use modification as well as hydrological regime with respect to the Kaveri River Basin. So over to you, Dr. Vinay.
Thank you, Bharat. Thank you for the introduction and motivating the people so that they can also take part in the conservation of the environment. I hope I'm audible.
Yes, you are audible. I'm just sharing the screen.
Yeah.
Yeah, hope it is visible.
Okay, I think we missed something in this one. It's fine. It's fine still. So, a very good afternoon to everyone. Can I continue? Okay, a very good afternoon to everyone. I'm Vinay. I'll be expressing my views particularly on how the landscape modifications are affecting the hydrological regime. So when I talk about hydrological regime, generally we speak about water cycle. Okay, so keep that in mind for those people who doesn't understand the terminology called as hydrological regime. Having said this, let's try to understand. Next slide. So what is land use? So generally when we talk about land or land use, set to next slide. So we need to understand. So when we talk about land and use, we have two different terminologies in here. So when we talk about land, we know that it's nothing but the terrestrial part of the Earth's surface, which basically encompasses over the biosphere, which can be something above the biosphere and below the biosphere also, because you have land, you have the surface, and you have the subsurface also. That's what we call above and below. So it basically occupies 30% of the entire Earth mass, which is containing the physical, biological, as well as the environmental things in the thing. Few things we need to understand is that similar to the resources what we have on the surface, the land resources is also little finite in nature. It is not infinite, it's not expandable. Okay, the land resources are not expandable. That's the reason we need to ensure that we have to save the land. And this land surface features basically interacts. What do I mean by interaction is it interacts with the society, it interacts with the environment, it interacts with the biological things. It also is necessary for the hydrological aspects, etc. So that's where land becomes one of the important aspects for us. Next. So generally when I talk about use, say to next. Yeah. So the use is basically based on the two terms. One is the biological terms. The second one is the based on human activities. Okay. If we talk about the biological aspects, you have the oceans, you have the rivers, forests, grasslands, which biologically modify themselves and vary accordingly. So you have the evergreen forest on one side, which is dependent on rainfall. Likewise, you have the sholas, then you have the peaks, generally in Chikmagalur and all those places, you have the sholas and the grasslands in there at the peaks. So you see that based on the variation in the rainfall, based on the variation of topography, the regional biology, these things start to vary. Likewise, when we talk about the human interactions, okay, we construct reservoirs, we construct lakes. So generally, most of the lakes, what you see in Bangalore, mostly they are sort of human made. So that's where we talk about the human based activities that comes into picture. Likewise, you have the other things that happens, such as the buildings, the roads, etc. All these aspects come into this. Further, if you talk about human aspects, it can be agriculture, horticulture, or even the monoculture activities. All these things form a part of a human-based management of the land. Okay, next. Next. Okay, so generally when you talk about land use changes, so we have two aspects. So we need to understand that these changes in the land uses are relevant in nature, like certain things cannot be avoided, right? Okay, so generally if you try to see, if I just talk about the term called as land use modifications. So this term land use modification or the actual things what you see on the ground, the modifications are basically because of population rise. We know that the resources are limited because of population rise. We have higher demand of resources, so we tend to change the resource. Likewise, the climatic changes. So what are the changes that are happening in the climate that is also leading to sort of land use change? We can see that the polar ice caps are melting down. So we have the glacier to water bodies. You can see those kind of changes are happening. Then you have the direct human activities. It can be something like construction of roads, construction of buildings, deforestation, degradation of forest. All these things comes under the modifications and the causes for modifications. Likewise, you have the natural cause. The natural cause can be something like earthquake or any other disasters that are happening in the system. So all these things will lead to something called as the effects. So on the left hand side, what you see can be the cause. The right hand side, what you see, the blue sheet, they're nothing but the effects. So it can be the climate change and global warming. See, because of land use change, we have these things happening, and we have the reduced per capita availability of resource because of the degradation. And there's a change in the hydrological regime. Probably, if you try to understand the hydrological cycle, let's talk about the concept called as rainfall. So the rainfall which is supposed to happen for 6 months, or it's supposed to happen for 4 months. So that will happen well within few months. Like let's say it can be well within 2 months. What do I mean by this one is the rainfall can be same, but the intensity will increase and the rainfall duration will reduce. So this will further lead to something called as flooding. So generally what we see the floods that are occurring in Bangalore are one of the cause, like because of the change in the hydrological regime and as a result of land use modification. So this can also lead to socio-economic concerns as well as the loss of biodiversity, etc. Typically, if you try to look across, the effect will again lead to cause. Next. So it becomes a cyclic aspect in nature. So to next. So next. So if you try to understand how the landscape has changed, so we directly can correlate our rate of change directly to something called as industrialization. Probably if you try to look at the graph on the top left corner, you see that in the year 1980s, okay, in the year 1980s, the forest was, the degradation was quite less, okay. Post-industrialization, you can see the rate at which the degradation is happening is very high. So we need to be very cautious about this. Likewise, if you talk about the right-hand side, you have a map of degradation, deforestation. So you can see that close to around 5,000 square kilometers of land is degraded in the year 2015 itself in Indian context. Likewise, for different parts of the world, you can see the rate of degradation that has been given in the graph. Similarly, does this has any relationship with the temperature dynamics? Yes, definitely it has. Just one scroll down. So we see that the temperatures are starting to rise at a rampant rate. And every year we hear that the hottest year recorded is from 2021 also we said that the hottest summer recorded, 22 we mentioned it, 23 we mentioned it, 24 also we are mentioning that this is the highest recorded. If you try to look at the last 10 years, the dark red lines, the right hand side of the graph, you see that the temperatures are rising at a very high rate. So typically if I correlate the forest degradation the top left and the climatic patterns in the bottom right, you see that the temperatures are raised by 1.5 degrees centigrade in the last 140 years. So this is a major concern. So we see that industrialization has directly impacted the forests, and this has directly impacted the local climatic changes. It can be both local as well as global, that we need to be cautious in mind. So this is one of the reasons why we should have some conservation practices. Next slide. So typically when we talk about conservation practices, we talk about why we need to do some conservation practices. It can be because we know that the land resources are finite, because of we need some environmental benefits. We need to ensure that we have particularly the food security being maintained in the system, followed by some economic benefits and the climatic changes. So for these reasons, we have to have some conservation practices. Having said these reasons, how do we do that? So we can do it basically based on designated protected areas. It can be something like you have a CRZ, you have something called as the forest types, it can be the wildlife or the reserve forest. Basically, you're going with some protected areas. Similarly, you can go with some sustainable land use planning. It can be sustainable agriculture, it can be sustainable water resource planning, anything pertaining to land use. You're planning in such a way that you're ensuring that you're reducing the use of resources as well as reducing the rate of pollution. Similarly, you have education and awareness program. So what we are having right now is one such program where we are trying to educate people through some knowledge what we have gained through last some years. Likewise, we can also go with restoration. Let's say you have a degraded landform, go with restoration of the landform. It can be desilting of lakes, it can be going for afforestations, or it can be social forestry, anything that basically helps in restoration of land use practices. Next slide. So for any of the conservation practices, there are various methodologies. Okay, so one such methodology what we can use is something like based on the use of remote sensing and GIS data or tools for various conservation practices. Why remote sensing and GIS? Basically, it involves data collection, analysis, as well as this analysis helps me in decision support. So basically, based on decision support, I can understand various things. It can be the causal factors, I can map them, I can anticipate or visualize the impact of the factors on the resources. So based on these things, I can go with some sustainable land use practices, and this sustainability can happen at a site level. So it can be very much site specific in nature. So having said this, what I will do right now is, I just try to give you a case study of Kaveri River catchment. So how the things are changing. Okay, so that's what we try to do. So we try to understand about the Kaveri River first, then we try to understand how the landscape modification is happening. We try to also speak about the ecological footprint or the eco-hydrological footprint, basically how the water is being utilized there. Then we'll talk about the sustainable management practices, what we can go ahead based on different scenarios. So having said this, let's talk about River Kaveri next. So when generally, probably most of you have heard about this River Kaveri. It's in the southern part of India, originating from Karnataka, traversing through Tamil Nadu and going to the Bay of Bengal. So this is how it travels. So it travels for a distance of close to around 776 kilometers. So the basic origin is in Talakaveri River, Talakaveri, which is basically at Madikeri, and it exits at Pazar Estuary. What you can see on the right hand side, bottom side, you can see that. But the other thing is that it basically makes a delta. The Kaveri has a delta wherein after for the last 10 kilometers or 20 kilometers of the range, it basically becomes a delta and it spreads across the entire region so that crop cultivation is made there. So typically it has an area of nearly 85,363 square kilometers. So of which 55% is covered in Tamil Nadu, 41% is in Kerala, Karnataka, 3% is in Kerala and close to 0.1% in Pondicherry. So the predicted population for the year 2021 is 44.75 billion within this catchment. Okay. And as of now, if we talk about the storage capacity, we have a total storage capacity of 316 TMC in the Kaveri River Basin, with 98 reservoirs. We have 160 TMC that is being stored in Tamil Nadu, 157 TMC in Karnataka, 13 TMC is being stored in Kerala. So we see that of this 98 structures, 37% of the structures are in Tamil Nadu and 57% of the structures is in Karnataka. And even so, we are storing a less quantity of water in the Karnataka bed as against the Tamil Nadu bed, where we have minimal number of reservoirs and maximum storages that are happening in the system there. Next slide. So typically, if you try to look at Kaveri, is one of the most disputed issue that comes across. Probably post rainfall, these things crops up every year. If you try to observe, so basically this is the verdict given by in the year 2007, wherein it says that Tamil Nadu should receive 419 TMC of water for its purposes, and Karnataka 270 TMC, Kerala 30 TMC, Pondicherry 7 TMC, environmental flow is around 10 TMC, and inevitable flow that goes to the ocean is 4 TMC. So this is the total water distribution that has been awarded by the Jal Shakti Nigam. So for this, the assumption is the water available is at the 50% dependability, and that is about close to 740 TMC. Okay, we go on to the next slide. Okay, next slide. So this basically gives you the variation in rainfall. Probably if you try to look at the last 110 years or 120 years of rainfall data that's available, if you try to look at it, it shows the variation. So on an average rainy season, so you see that in the Western Ghats, you have rainfall close to around just over 5,400 millimeter, whereas in the central part, where in the Deccan Plateau part, you see that the rainfall is as low as 470 millimeter. And when you go to the coastal areas such as Tamil Nadu and all those places, again you have higher quantity of rainfall, somewhere around 1,500 to 2,000 millimeters of rainfall. So you see that the transition is clearly shown in that one. Likewise, you have different kinds of soils. The soils can be of various things. It can be something like the coastal alluvial soils, the deltaic soils, and many more things. Similarly, you can see the lithology. Typically, the lithology is dominated by the gneiss rock types, which is nothing but the secondary form of granite. So the elevation in this region varies between minus 12 meters with respect to the mean sea level, the global mean sea level, that's what I mean here. With respect to the global mean sea level, it raises between minus 12 meters to somewhere greater than just 2,600 meters above the mean sea level, particularly in the Ghat portions of Tamil Nadu. So if you try to talk about the last one, what you see in this one, it shows you the different kinds of reservoirs that are available in the system. So 98 different reservoirs have been showcased as point databases. And this particular thing, you can see the dark ones, that's nothing but Stalin Reservoir, which has more than 50 TMC capacity. So based on some ranges, we have just put these numbers. The actual numbers are not being represented here. What I mean actual is, you have the actual numbers of the gross storage. So, but for representation, we have used some shades. So let's try to talk about the method what we have used for further analysis. Next slide. So generally, if I want to understand about the eco-hydrological footprint or nothing but the footprint of water, we need to understand what's the water required for irrigation. We need to understand the water required for evaporation. Why evaporation? Evaporation is one particular thing that is basically we assume it for the forest, that is very much essential, because without evaporation you don't have the hydrological cycle that gets completed in the system. Similarly, the demands, when you talk about the water demand, is there for agriculture, domestic, livestock demands. These are the things that we have considered in the thing. So basically, you have the data that you collect from the field investigations. Based on the field investigation data, as well as various other data such as the IMD-based data sets or the soil data sets, all these data sets you collect. Based on the collection of data initially, if I talk about the landscape mapping next, if I try to talk about the landscape mapping, you see that we collect the data. So this remote sensing data is further analyzed. So we do some pre-processing of the data, and you do the georeferencing. Further, you go with classification. This classification in the recent past, you can use something called the machine learning and AI-based tools. So which will also give you a faster, give you the information at a faster rate. So that's what we can do. So basically, we are trying to understand the land use for different time periods. So based on the historical maps, we have taken the French Institute maps for the year 1965 to understand how the forests were there. Whereas in the current, we have taken it for the year 2016 and 2023 to understand the deviations in the land use. Likewise, next, we can also try to understand the precipitation, like how the runoff happens based on the rainfall data that would have occurred from Indian Meteorological Department, as well as you have various other portals such as NOAA or climate change. Other portals are there where you can download the data. So based on that, if you try to observe the runoff, uh, we have used something called as the natural resource conservation series method, which is one of the mostly used method, commonly used method. So based on that one, we are trying to estimate the runoff at the annual scale. Similarly, we try to estimate the what you call the infiltration rate as well as the groundwater availability in the system. Next. So this gives you a flow of how the infiltration is being evaluated. Likewise, we also try to estimate what's the crop water demand. Next. Further, based on the census data, please understand that in the year 2021, there is no census data that's being made. So we have to make an estimate based on the 2011 and 2010, 2001 data. So we had an estimate of that one. So we know the population growth rate, we predict the population, then we try to understand the per capita water demand based on next. Further, to understand or to derive sustainable things, we try to categorize this into two parts. So first thing is that you have a normal rainfall event. Okay. So here we have used something called wild climate data. So with respect to that, we have an average rainfall of 50 years. So based on the average rainfall of 50 years, we have two different scenarios based on two different cropping patterns. Likewise, I know what's the coefficient of variation. The GPCC is directly related to IMD also. IMD provides data to GPCC. So we have taken the variation of rainfall. So this coefficient of variation was used to define the drought scenario. So based on this drought scenario, again, based on the cropping patterns, we defined two different scenarios. Basically, we have two rainfall scenarios and two cropping pattern scenarios. Accordingly, you have one thing called as for the normal rainfall event with two different cropping types, and you have a drought event with two different cropping types. Let's go next slide. So what you basically see here is basically the land use for the year 2023. We can see that the Ghats portion is mostly dominated by horticulture and plantation. When I mean plantation here, it is basically both your agriculture-based plantations as well as the forest-based plantations, which basically include your teak, includes your acacia, areca nut, coconut, banana, coffee, etc. All these things come under this plantation activity. We see that the Ghats, where you have the higher rainfall, mostly they are dominated with plantation activities. And you can see this C-shaped curve, like wherein you have the connect from the Western Ghats that's going through Bangalore, and it basically connects the Eastern Ghats. So that's the one of the major forest range what you can find here. You have Bandipur, you have Nagarole, and all those places in the system there. Similarly, you can see what you see in red is basically urban areas. You see that what you see on the top right corner is basically Bangalore, north of that one is Tumkur, and you have Mysore, Madikeri, and all those places that can be seen. Whatever you see on the green, the larger green section, above that one basically is the Karnataka part. Below is basically the Tamil Nadu part. You can see various reservoirs that are there in Karnataka. The blue shades basically depicts various lakes and various reservoirs that are there in Karnataka. Typically, if you try to look across, so nearly 13.5% of the total area is covered with dense vegetation. That's nothing but dense forests. You have nearly 4.4% of the area covered with degraded forests. And the water body is closely 1.41%. Agriculture is nearly 47.9% of the area. Plantation activity is nearly 22.7%. Built up 4.03%. Others are 6.2%. If I try to compare this changes or the changes in degradation, probably you'll be able to visualize that. So probably in the year 2016, when I tried to speak about, you see this, in the year 2016, the built-up spaces was close to just 3.65%, whereas in the current year, with smart cities and all those things coming up, we see that the built-up spaces has increased to 4.03%. The number looks small, multiply with the area of 85,000 square kilometers, you'll get a very big number. So we need to understand that rampant urban growth or rampant changes in the landscape is happening. Because of this rampant changes, we have a large-scale degradation of forests and other natural resources that are available in the system. Next. So now let's try to compare the forest change. So in the year 1965, based on the French Institute maps, what we tried to take it. So it shows that nearly 33% of this entire area was covered with forest, which includes both degraded and dense forest in here. Likewise, in the year 2023, we see that the forest has reduced to just as close as 18%. And this forest includes even the open forest also in many cases. Okay, this open forest behaves as good as grasslands in many cases. You have the varied hydrological regimes in those areas. So we need to be pretty cautious in those things. Next. So based on the data, based on the rainfall, if you see that, probably initially I showed you how the annual rainfall is there. So probably in the initial slides, I showed you how the annual rainfall is distributed. But if you try to look across different months, how the rainfall distribution is happening, probably the southwest monsoon mostly caters to the Karnataka part and Kerala part. You can see that the Karnataka part, the Ghats, you have the very high rainfall in this during the southwest monsoon, particularly in June, July, August, and September. Whereas the Tamil Nadu part basically receives a pretty good amount of rainfall in the months of October, November, December to January. What do I mean by this one is the southwest monsoon caters largely across the area, but is mostly prevalent to Karnataka, whereas in the Tamil Nadu part, it is quite less as against Karnataka in the southwest monsoon, whereas the northeast monsoon contributes higher to the Tamil Nadu range as against Karnataka range. Next. So, back. So typically, if you try to look across, you have a gross rainfall of 2,847 TMC. It's a gross rainfall. So we have to subject this to the hydrological or the water balance. So then only we'll try to understand what's the availability. So next we'll try to understand runoff. So this runoff was estimated using Natural Resource Conservation Series method. Next slide. So accordingly, we try to estimate for each and every catchment. So we see that how the things vary. It ranges between less than 250 mm in this particular blue shaded areas to greater than 750 mm in the red shaded areas. We see that higher runoff is happening in the Ghats compared to the plain areas. So next one slide, one click. So typically, if you try to look at runoff, basically with an average rainfall, okay, with an average rainfall, you have close to around 789 TMC. Okay, so this is the average rainfall of the average 50 years rainfall. Based on that one, you have 789 TMC of overland flow that goes out of the system. Next, similarly, you can estimate infiltration as well as groundwater recharge. That was again using the standard techniques what we have used. Next. So typically, the infiltration ranges between 10 TMC to greater than 30 TMC. So you see that at the coastal areas, based on the soil type and the slope and other parameters, we see that very high infiltration is happening in the plain lands as against the Ghat section, as well as against the inlands of particularly in the Karnataka part, because of the hard soil and the granitic biomass there. Sorry, the granite and other soil, rocky type what you find there. Likewise, on the right hand side, you can see how much the groundwater is recharging. Mostly in the Ghats, you have a higher groundwater recharging, and at the coastal areas, you have a higher groundwater recharging that is happening in the system. So typically, close to around 967 TMC of water gets infiltrated. Of the 270 TMC of water gets recharged as groundwater. Next. Okay. Further, if you try to evaluate evaporation, so we need to understand that evaporation is directly a function of temperature variations, the regional humidity consideration, regional humidity, and the land use pattern. All these defines the operation in the system. So typically based on the variations in the temperature. So what you see on the right hand side is basically the variations in the temperature. You see that the maximum temperature reaches in the month of April, May. So that's where you have very high temperatures, April, May, June, and July. So particularly in the parts of Tamil Nadu side of the region, you have very high temperatures compared to the Karnataka region. So because of the variation in the topography and the climatic patterns. So typically the total evaporation, what it comes up to. So we have used here something called as a modified Hargreaves method, which considers the temperature modifications, the solar irradiation, and the sunlight and the sunlight duration, all those concepts. So typically you have a total evapotranspiration of close to around 545 TMC, which directly goes out of the system. So further, as I said to you, if you try to understand the population dynamics, you see that how the population is ranging over space and time. We have close to nearly 45 million people. That's what I mentioned in the initial slides. And you can try to see across different states how much it is varying. So Tamil Nadu contributes the highest population, followed by Karnataka and Kerala. So typically the annual water demand for the entire Kaveri basin is close to around 78 TMC. Next. So where do you have higher water demand? Particularly look at the place such as Bangalore. So this corner, what I said, that was Bangalore, the red side, the red color, what you see there, it's basically Bangalore and other areas and the neighboring areas. These are the regions which is demanding more and more water because of the population in the system. Similarly, wherever you have the larger area and more urban population, you have higher quantity of water that's required for domestic water needs. Next. Similarly, we need to take into consideration the livestock water. So wherever you have higher livestock, so particularly you can see that the southern part, the downstream part requires higher quantity of water, close to more than 150 million cubic feet of water is required in the downstream side. But in the upstream side, particularly in places such as Hassan and Tumkur and those belts and Mysore, those belts you require around 100 to 150 TMC of water because of the presence of more and more livestock and cattle in those areas. Likewise, along the Nilgiris and closer to the range of Erode and all those places, you require higher water because of the cattle and other animals which are in plenty. Typically, on an annual basis, nearly 9 TMC of water is required for the livestock. So if you try to understand the crop water requirement, so this crop water requirement you cannot directly evaluate because when you try to do the land use analysis, it's difficult for you to evaluate what kind of crop it is, or else it becomes more and more intensive to understand. So for that one, we used both the land use maps as well as the secondary data such as the crop area at each and every district or at the taluk level. So that we try to correlate and estimate at each and every catchment level. So typically you can see that the first top left corner what you see is basically paddy. You can see that where paddy is grown more. Okay, you can see that the coastal belt wherein the plain regions paddy is grown more. Likewise, Hassan to Mysore, those belts, you have more and more paddy being grown there. Similarly, you have maize, jowar, etc. etc. So basically you can see that pulses is mostly grown previously. Pulses is mostly grown in Karnataka part. Mostly you can see that yellow and greenish shades mostly in Karnataka, yellow, green and red shades. We have more pulses being grown. Likewise, more oil seeds are being grown. We can see that what kind of areas, what kind of crops are grown here. We can see that the crop visibility which is basically happening in the system. So you have more pulses are being grown, more oil seeds are being grown, more fruits, more vegetables are being grown. And sugar cane, you can see that they are grown at particular belts. It's not grown everywhere, it's grown particular belts such as Mandya, Mysore belt, and particularly in the coastal part of the Tamil Nadu district, we have more sugar cane that's being grown. Next. So typically based on the different crop type, based on the growth phase, if you try to understand the crop water requirement, whether it's a single crop or whether it's a double crop, you need to consider all these parameters. So accordingly, if you try to estimate, you get close to around, and then like, so accordingly, if you try to estimate, you have a water demand for agriculture itself as 1,188 TMC. This is a total water demand based on the water that is required for each crop, assuming that the complete portion is given to that one. Next. So now let's try to understand three different scenarios. So initially, based on the existing crop water, based on the existing multi-crop, which let's say if it continues as it is. So in that case, we have nearly 1,188 TMC of water demand. Now, assume that I am replacing sugarcane by paddy. Why? Please understand that sugarcane is a perennial crop and you require water throughout the year. Okay, so if I replace that with paddy, so my water requirement reduces and it condenses mostly during the monsoon time itself. Like it can be catered during monsoon time itself. In the post-monsoon, you can go with pulses and millets so that with whatever the moisture available in the system, they can grow. So accordingly, if you try to look at it, the total water demand becomes close to around 943 TMC. Now, let's have one more scenario. Assume that I take sugarcane completely and I reduce the paddy by 50% and ensure that I grow more and more pulses. So we see that nearly 787 TMC is the water demand. So if you try to look at the water demand to supply ratios, in the scenario 1, you have a demand to supply ratio of close to around 0.66 because you have higher water demand. And in the second scenario, you have a demand to ratio of 0.8. You see that with just replacing one crop, which is extensively water intensive, you see that my supply to demand ratio starts to reduce. Similarly, if I completely remove sugarcane and if you go with paddy, you increase the cultivation of paddy and grow more pulses and millets, you have more and more of demand that is being catered. So we see that most of your demands get easily catered just by changing the crops. Now let's go with the new scenario. Let's say that the rainfall is varying. So typically we try to understand the coefficient of variation. Based on the minimal coefficient of variation or the maximal coefficient of variation, we try to arrive at rainfall that is likely to happen during the droughts. So we see that the very high coefficient of variation is in Bangalore and its neighboring places, whereas the Ghats have the lowest coefficient of variation and the coastal areas also has very minimal coefficient of variation, which is quite standard in India. So assume a drought rainfall case. What is supposed to be around 5,000 millimeter of rainfall in the Ghat sections? We have just over 3,000 millimeter or just over 2,000 millimeter of rainfall in the Ghats. And in the coastal areas, the rainfall is reduced from 1,500 or 2,000 millimeter to as close as 750 to 1,500 millimeters. We see that variations that are happening. And in these areas, the dark blue areas, you can see that is a rain shadow areas wherein your rainfall is as low as 500 millimeter. So assuming a rainfall event when you have a drought, so accordingly we can arrive at this. So based on this one, if you try to evaluate the runoff, so what we see is during the southwest monsoon, we have close to around 191 TMC of water that comes through as a runoff and 45 from the northeast monsoon, particularly in Karnataka. If you try to look into Tamil Nadu case, it's quite opposite. Southwest monsoon, you have very less overland flows, and the northeast monsoon, you have very high overland flows, typically 203 TMC. So overall, we see that nearly 536.8 TMC of water goes away as overland flow to the system during the drought season. So similarly, if you try to understand the water availability, so initially assuming that the crop water requirement is as it is, and minor changes in the supply, so we see that the supply to demand ratio falls down to 0.45. Then, the removal of sugarcane and reducing the fertility for the second scenario that's what we mentioned earlier. So according to the one, we see that 7% is the water demand and 5% is the water supply. So accordingly, I just supply to demand ratio 0.68. Similarly, we have third scenario wherein you are adding the crop water and you are trying to use some groundwater in some context. In that case, what happens is that if I remove sugarcane and reduce paddy by 75% and other crops by 30%, I start growing more and more millets. In that case, my demand is 692 TMC and my supply to demand ratio is 0.94. Similarly, in the other scenario wherein I am completely removing sugarcane, I am reducing paddy to close to 30%. Instead of 75%, I reduce the paddy to 30%. So in that case, what is happening? I'm having a demand of 638 TMC, which may supply 657, which includes groundwater. So what do I mean by this one is, your groundwater, which was basically supplying, we assume that the groundwater is basically catering to the domestic needs. So in this case, we said that we'll also take groundwater that will also cater to the agricultural needs. So you have different scenarios. Based on the different scenarios here, you have different supply to water demand ratios, and we see that how we can manage the crops and how sustainably we can ensure that the water is available in the system. Next. So the idea is, so you see that on the left hand side is the normal rainfall event, on the right hand side is the drought rainfall event. So we have given different kinds of crops that can be grown. If the rainfall is less than 500 millimeter, what kind of crops to be grown, and if the rainfall is greater than 2000 millimeter, what kind of crops can be used in those systems. So accordingly, what we have done here is we are trying to propose what kind of crops that can be grown according to the season. Next. Next. So this is what we can see. The scenarios what I explained there. Back. Back. The scenarios what I next. Okay. So based on the different scenarios what I explained there, if I want to have a sustainable cropping, or if I want to go for crops during drought, what kind of crops I have to do? Initially, if I curtail Initially, if I curtail sugarcane, later on I curtail paddy by 50%, 75%. Sometimes during a drought scenario where you don't have rainfall, I curtail completely paddy. So you can see that with different scenarios, my crop water demand starts to reduce. So basically, what we are trying to say is, if you properly manage the landscape, you can easily ensure or you can easily manage the water resource there. Next. So based on some of the field observations, what we had done. So if you try to look at this,
Thank you, Vinay. Thanks for sharing on more details about Kaveri Basin. So now I request Dr. Chandan to share about urban issues so that we can discuss. Now we understood the Kaveri River Basin in detail. So now I request Chandan to share urban issues so that we will have a combined discussion in the end.
Good afternoon to all the participants. Am I audible?
You are audible. Chandan, can you share your screen?
Yes. Yes.
No, I came for complete classes. But for some subjects I didn't, but because I'm taking a different class. I went to the question. I guess I attended two classes.
Okay, I have shared my screen. Is it visible?
Yeah, it is visible.
Video is video required? Can I turn off the video?
Yeah, your wish, your wish.
Okay. Actually, I couldn't turn on the video. It is not allowing.
Okay. Yeah, no issues. Video is not required. You can continue. Chandan, you can continue. Hello. Hello. Hello, Chandan, can you hear me?
first classes before.
Second,
This is first one. Fourth class. But other classes, okay, that would be three.
Hello. Good afternoon.
Chindan, we are able to hear you.
Yeah.
Can you start from the beginning because there was some
Sure.
issue?
Sure, sir. Sure. No
Okay,
problem.
sorry.
Yeah. A very good afternoon to all of you. Uh, I welcome you all to this workshop on World Environment Day, focusing on two important aspects, that is the water issue, as it has been discussed by Dr. Vinay, and another one is the urban issue itself. Um, I would like to thank Dr. TVRAMACHANDRA and Dr. Bharat Setturu and Dr. Vinay for providing me this opportunity to present my research on urban data modeling for Indian cities. I am Dr. Chandan MC. I am an assistant professor at the Department of Civil Engineering, NIE Mysore. So to set the context, as we all know, there are certain pre-existing metropolitan cities which have reached the threshold. For example, we have Delhi, Kolkata, and Mumbai in terms of resource utilization and resource exhaustion. Whereas if we look at the new cities or the newer urban agglomerations like Ahmedabad, Pune, and Hyderabad, they are picking up the pace, and very soon they are going to overtake these older cities. The problem lies with the planning and visualization, because we are looking at a holistic planning for any of these cities. So this is very much required to minimize the illegal land acquisition activities, to minimize urban sprawl, and also to avoid land degradation and fragmentation. So with this, we can achieve the balance, natural balance, which is very much required for the ecosystem, along with attaining the sustainability of resources. So for this particular urban planning, we have to focus on the Sustainable Development Goal number 9 and Sustainable Development Goal number 11. Moving ahead, we have this challenge in terms of the huge data sets. India is rich with all the data sets. They are already there, they are available. But the problem is with the retrieval of the existing data. So this is causing major hindrance for the researchers. And also, I would also like to speak upon this in my later slides, where we have developed a decision support system which is called as SDSS for urban monitoring. And this is going to be useful for analyzing the spatio-temporal patterns of urbanization in India. The next question is, where do we get the data from? So data acquisition is the first step. And of course, it is worrisome for many of us because we really don't know or don't try to understand from where we are going to get the data from. But if we look at the Indian scenario, since the year 2010, our Indian government and the state government agencies have set up many of websites for sharing, especially the geospatial data in various sources. So generally, when we speak about the spatial data acquisition methods, it can be classified into ground-based acquisition where we conduct interviews, we do the land surveying, for example, we do total station survey, and we also use some numerical models to get the data. The second method is laboratory measurements of samples, and we also have measurement in situ sensors. The second kind of data acquisition is about getting the data spatially. So this is an image-based acquisition. So if you want to get the data in terms of an image, we need sensors, right? The sensor can be an aerial camera, the sensor can be a UAV or a drone, the sensor can be mounted on a satellite. So this is sensor-based data acquisition. On the other hand, we have sensors such as the active, we call it as active sensors, the radar and LiDAR, which basically works on the radio detection and ranging and light detection and ranging. Moving ahead, here there is one small video clip where we have the PPK drone, that is position corrected drone, and this was the demonstration of that drone that we had conducted the survey for our institute. So we can collect the data using drones as well. And on to the right, you can see the unrectified imagery. Okay, why I am specific about this is we have to do a geometric correction which is called as orthorectification. So this image basically is not yet orthorectified. So that is why on to the top right, you can see, a discrepancy in this tree cover. Okay, so this discrepancy can be taken out when we do the rectification. Other sources where you can get the data is Survey of India. They have launched open series maps. You can visit this website and download topographic maps of the scale 1:50,000. Our previous speaker, Dr. Vinay, was sharing details about the water scarcity and how it has been transformed from at least 3 to 4 decades ago. What was the water situation, and currently what is the water situation? So here, as you can see, this is the topo sheet for Hyderabad, and there are 3 important lakes. There are of course many other smaller lakes, but there are 3 important lakes, and how you can use this lake data. For example, you can take this topographic sheet and make use of this particular lake data for your analysis. The second source what I am explaining here is USGS, that is United States of Geological Survey. So this has huge repository of satellite data starting from 1972. We have Landsat, Sentinel, even Indian missions like IRS List 3, List 4 is also available in USGS, and the resolution what you can get is to up to 10 meters. The third one, our own Indian that is data source, that is Bhuvan. So Bhuvan is equivalent to the Google of Indian version. So it is a geo platform that has been made available by ISRO and NRSC jointly. And here we can get the satellite data products up to 23.5 meter resolution. For example, IRS list, there is Cartodem, You can also get 5 meter or less than 5 meter resolution, provided you will log into that portal and you have to place a purchase request. Many of the data they have now made it online for free, but you need to give the purchase request. Next is OSM. OSM is one of the favorites data source for geospatial engineers. So in the OSM, we can get vector data sets. Basically, this OSM is meant for vector data sets. We have the preloaded points, lines, and polygons in the GIS format. So if you want any kind of roads, railway network, locations of hospitals, location of schools, all these urban data sets are available in OSM. Next, we have the Google Earth. All of you might be aware of the Google Earth. It is the improvised version of Google Maps. Why I am saying this as an improvised version is because Google Maps is just to visualize. So today we are using geospatial data in each and every aspect of our life, starting from whether it is Ola, Uber, or Swiggy. We see that where the cab is moving and how it is coming closer to my location, right? So how this runs is what is behind the Google Earth. So here you can create the data of your own. Okay, you can extract the data as buildings, terrains, and more, and everything is for free. Last and the most powerful data source and generation is what we call as Google Earth Engine. So it is a huge repository. It contains multi-petabyte catalog of satellite imagery. As I mentioned, starting from 1972 till date, we have all the satellite imagery that is present. Only thing is you don't have to download any of these data to your systems. So you can work on cloud. So this in turn is connected with your Google Drive, so that all the data and the download what you do will be downloaded in your Google Drive. So now we have understood the data sources and where we can get the data from. The next question is, what analysis will you do? So when we look at the urban area and urban sprawl, if you have to identify, urban area, the definition ranges from country to country. However, if we see the history of urban area, humans have always started settling adjacent to rivers, whether it is Harappa, Mohenjo-daro, or Egyptian, timeline. Always the human settlement is very adjacent to the rivers. That is how they start dwelling. And urban sprawl is something which is interesting because it is a low density urban settlement and it is monocentric compared to the city into the dispersed or discontinuous or fragmented, wherein we are talking here about polycentric urban patterns. Polycentric means it can happen in the periphery, it can happen anywhere around the main urban areas. Then if we look at the sprawl, we have three major types of sprawl. One is called as the low density sprawl. Second one is the ribbon density sprawl. And the third one is called as leapfrog sprawl. Now let us understand how this is further divided. So in this picture, you can see the low density sprawl, Bangalore can be taken as an example. And for ribbon sprawl, you can take Delhi as an example. So what is the difference between these two? Low density sprawl generally happens this central business district fills and the surrounding area gradually starts filling. Whereas if you consider the Delhi region, it is a ribbon kind of a sprawl where specifically on surrounding areas like Noida and Ghaziabad, they are getting urbanized much faster than other regions. So this is called as ribbon sprawl. Whereas leapfrog sprawl is generally experienced in cities like Mumbai. Why? Because in Mumbai we have land restriction, right? The land can, you can utilize the land for urban areas only on one direction. So that comes under the leapfrog sprawl. So next we have something called as the Ahmedabad is the best example for the edge expansion. Sorry, Chandigarh is the best example for edge expansion, wherein the edges or the boundary lines of the city gets expanded at much higher rates. Okay, and finally we have the last type, that is spontaneous growth. Ahmedabad and surroundings can be experiencing the spontaneous growth. So to analyze the major cities of India, we have taken 10 cities of India as it is listed in this table, and the areas which are considered for those cities are mostly the Greater Urban Development Authority area. That means it also consists of the core central business district along with the entire region. And this particular slide shows you the details of the transition of the land use of 10 cities of India, starting from 1990s to the recent data set, that is to 2020 or 2019. And you can see this has been divided into 3 different types or the categories. And that is R stands for rapid, G stands for gradual, and also we have M, which stands for moderate. So in this, let me take the case of Ahmedabad. Ahmedabad has transitioned gradually from 1990 to 2017. That is the urban cover. If you see, it was 7.03% in 1990, whereas it has reached 19.35 in the year 2017. Whereas if you see the rapid transition has happened in Coimbatore. So here you can experience 1.87% of urban area in 1991, whereas in the year 2017, if you take it is 17.88%. As I mentioned in the first slide, the metropolitan cities, for example, if I take Delhi, Delhi was supposed to be a metropolitan city during those times. So if you look at the transition during 2003 and 17, it has gradually attained the transition and now it is saturated. Same is the case with Mumbai. So how do we foresee what is going to happen in the near future? That is our next question. So this research gap is addressed by models that is famously known as urban growth models or urban models. So this can predict the future urban growth using the simple transition rules. How are these simple transition rules framed? This is framed using a very famous algorithm which is called as cellular automation. So cellular automation will give you the transition of urban growth with respect to spatial aspect. Now we are talking about spatial aspect as well as temporal aspect. So that is what it makes as spatio-temporal aspect. So if you want to include the temporal aspect, we need Markov chains that are spatially non-explicit, not only because it will give us the probabilities, but it will also give the best probability for land use transition where the traditional approaches fail to predict complex urban patterns. So when we have the robust system consisting of cellular automation, Markov chain, along with the artificial intelligence and the stochastic optimization process, it will give us very deep theoretical understanding of the urbanization as well as prediction for the future. So this map shows the different types of urban growth models, different subcategories as well. So here we are concentrating mostly on cellular automata and cellular automata based genetic algorithm, sleuth genetic algorithm, and so on. So now if we take the case of one of the very well tested model, that is sleuth urban growth model. It is a cellular automata based model. It has certain rules to play with, and the sleuth term itself stands for slope, land use exclusion, urban transportation, and hillshade. So that is the acronym. And here the parameters are the diffusion, breed, spread, slope resistance, and road gravity. So I will explain what are these, but along with these parameters, we have certain coefficients. If you look at this figure to the right bottom, we have spontaneous growth. That means there is one cell here which is urban, and immediately to the urban there is another couple of cells which are at a distance, which is happening spontaneously. And then we have the diffusion or spread of a new growth center. That means you have the CBD, which is in the black color, corresponding to the CBD in the adjacent or in the periphery. You can find other cells which are developed. So this is called as diffusion or spreading kind of a growth. Then we have the organic growth. Organic growth generally happens in the edges. Okay. And then we have the road influence. As you know, road is the backbone of the country. So whenever there is a new road that is being constructed, 100% you can expect some kind of development that is going to happen very adjacent to the road. So that is called as road influence growth. Now, what input data do we require? So as I already mentioned in the previous slide, sleuth stand for slope, land use, elevation, and urban and transportation. So here you can see this is the slope layer that has been taken for Chandigarh, land use for 2 different time periods, 1999 and 2017. And then you have the urban area for 4 different time periods, road network for 4 different time periods, right? And also we have excluded region. What do you mean by this excluded region? So you can concentrate here. This is the excluded region in black color, which is basically the, there is one lake in Chandigarh. Okay, and then adjacent to that there is a rock garden. So this particular lake area and the garden area have been classified as excluded. Why excluded? Because we are saying that we are going to protect these areas from future urbanization aspects. And then we have hillshade. So this picture shows you the general workflow of the sleuth model and how it works. So here you can see, you have the standard input layers in the form of slope, land use, excluded, urban, transportation, and hillshade. Then you have the scenario file where this scenario needs to be calibrated for each of the cities, because as you know, Indian cities are very dynamic, so it is getting influenced by a lot of factors. So we cannot keep the same scenario for each and every city. It will be different, of course, for different cities. And during the calibration, we have 3 different types of calibration. One is called as coarse calibration. So let me tell you, this calibration is completely based on the resolution of the input image. So in coarse calibration, we take the resolution as 120 meters. Calibration, we take 60 meters, and in final calibration, we take it as 30 meters. So once we have calibrated, we then choose the set of coefficients based on the Lee Sallee value, and that will be used for the prediction for the near future. Now, as I mentioned, along with the classic models like cellular automata, sleuth, and Markov chain, we also need some AI and some machine learning to go with. So that will help us to optimize the entire process and get accurate results. So for this purpose, we have tried with 2 of the AI techniques. That is, one is genetic algorithm. So it is a classical model as explained by Holland, where it is based on the Darwin's survival of the fittest theory. So each generation will have their own, it is based on the biological concepts. Each generation will have their own kind of genes, and in each generation, the best set of genes is taken to the next generation. So here we experience something called as crossover and mutation. And also there is one more theory called as elitism, where the best of the best genes are taken for the next generation. And then we have another classic optimization technique, which is called as particle swarm optimization. So here basically you might have seen the flock of birds in the evening, how they go in synchronization, right? So all birds are treated as particles, and they have a fitness value, and it can be calculated with the help of the objective function, which I'm going to show in the next slide. So each of these birds will have the bird's personal best and global best performance, right? Personal best is attached to an individual bird, whereas the global best performance is attached with the flock of the birds. So here we can see how the particle swarm optimization works. So we have 3 different components. The velocity updation of each bird happens with respect to the inertia weight. That is the first part. Then the cognitive component, wherein we go with the local search. It has mostly the influence of personal influence is present here in the second part. And the last part is the social component, where it is a collaborative effort by all the birds. So what is the final aim of all the birds? The final aim of all the birds is to reach the food as soon as possible. Okay, so if you want the birds to reach the food as soon as possible, there should be certain geometry that needs to be maintained with respect to their position. So this position updation is going to happen with respect to this equation. So here you can see the t+1 is the next time period. If a bird has to reach the next position, it is dependent on t, that is the present time, along with the velocity. Present time and velocity both are important. So we have experienced these kind of techniques onto various cities. For example, this particular result is given for Chandigarh. We experienced Chandigarh by putting the urban growth models, specifically the genetic algorithm and particle swarm optimization. So the results were pretty impressive and interesting as well. So here we can see it is the spreading growth that has been experienced in this region, which is marked as A, basically the Kharar region, where we have the NH95, which further connects the Chandigarh region to Ludhiana. And then spontaneous growth, as we discussed in our starting slides. So where the new centers will come up immediately adjacent to the core areas, and these are detached individual urban areas. You can see here in which is marked as B near the Kurali Road. Then we have the organic growth. Okay, this is basically the edge kind of a growth. So this happens in Pinjore and Kalka region. This is basically due to the tourist attraction for a dam. There is a Kaushalya Dam, and also it goes on to connect Shimla. And the final type of growth is called as diffusive growth, which can be experienced near the airport and Zirakpur industrial area. And also we have predicted how the urban area looks for the near future. And this is the statistics of the percentage of urban cover for the 2025 year. And as mostly the research has been done for the entire Bangalore region, I think very recently I was just reading about one of the research that has been conducted by Tulika and Professor TVRAMACHANDRA. I think these results are very close to the results what the IISc research team has also got. And we also performed scenario-based prediction. In the previous talk, you just saw various scenario of if you grow only paddy or sugarcane, how it is going to affect the water requirement. The same kind of study where we specify 3 different scenarios. The first scenario is the one where we put the low restriction. The scenario number 2, medium restriction. Scenario number 3 is high restriction. Of course, here you are able to see 1,400 square kilometers on one image. That is why you would not feel that in all the 3 scenarios it is the one and the same. But when we look into sub-regional analysis, that is region-specific analysis, we got to know that, for example, Himayat Sagar showed the diffusive kind of a growth, whereas the Shamshabad Airport, International Airport region has spontaneous growth. That is definitely, it is quite obvious because once you have the airport, you have all the amenities that is coming next to the airport very spontaneously. Then we have the Hakimpet region where we have the spreading kind of a growth because Hakimpet is considered to be the older part of the Hyderabad city. Further, once we do all this kind of data modeling and data prediction for the urban growth, we need to put all these things on a platform so that the users, end users, can easily visualize this. For this, we have built something called as a spatial decision support system in the name of spatial web-based analysis for urban transition. It is also called a SWOT. So this portal will give you, the details about the smart cities. It has analysis. You can do the, if you have the data of your own city, you can perform analysis online. So you can use this website for that. And also currently we are working on the Bangalore-Mysore Expressway corridor. It has 2 different components. So the recently constructed Bangalore-Mysore corridor, where how the growth is going to happen adjacent to this expressway corridor, that was one of the objective. And the second objective was socio-economic objective, because since this expressway cannot be accessed. So the earlier we used to have Mysore-Bangalore highway road. Adjacent to the highway, there were a lot of livelihood that was, in the form of small shops, and now all of them has lost their jobs. So how it has affected mass of the people, that was another part of the study. Then in another interesting study, we conducted Mysore and Mandya district groundwater potential map. So just I think in the previous talk, you have understood about the importance of water and also groundwater. So here we have used a technique called as AHP, that is analytical hierarchical process, and machine learning, basically random forest, for estimating what is the groundwater potential zones and how it can be effectively utilized for agriculture and other needs. So this particular map shows the groundwater potential zones in and around the Mysore and Mandya district, and how the distribution is happening, where you have the highest distribution and where you have the low distribution. So 1 or 2 slides I want to concentrate on this spatial data and geospatial domain. So that is the remote sensing and GIS. As you know, the game changers in the coming days is the geospatial AI and ML, and also we have drones. So you might be aware that the PM recently launched Drone Didi program, where each and every taluk should be, skilled to fly a drone in their particular agricultural fields. So mapping services also getting demand. Autonomous vehicles are also getting demand. So recently, if you have seen the last 3 to 4 years data, all the banking sectors, they are using direct satellite data for credit assessment of farmers based on how much crop is lost due to the drought or flooding, and they'll give the compensation based on that. So if you want to give a report based on the crop yield or crop estimation, that can be done using the satellite data. And there are plenty of opportunities, PhD opportunities, okay, but you need to be very specific about your topic, and you always have to have a good relationship with your supervisor, whether it is choosing the topic. And PhD means commitment. So once you are committed for the topic, you need to do some hard work, and you have to be dedicated to get a PhD degree. So another important slide, I could say, the next question is where to do the PhD or the postdoc. So here I have listed few of the grants which are available by both Indian government and other governments from abroad. One can use this as the stepping stone for their PhD or postdoc studies. So this is the outcome of the research, whatever we have done so far. We have been able to publish in many of the renowned journals as well as book chapters from famous publishing houses. I'd like to thank all of you for attending this session. If you have any queries, we can take it up. Thank you, one and all.
Thank you, Dr. Chandan, for throwing light on urban issues, and you highlighted the how the urbanization takes place and what are the various patterns you observed in the growth of the cities, and it's very interesting. And along with that, Dr. Vinay highlighted the water issues. When you face lot of urbanization, how the water demand will increase, and because of water demand, how the also the crop and other demands increases. So we clearly got a picture about urban as well as water issues. Now the floor is open for the discussion. So if the participants have any questions, you can feel free to ask questions. So over to the participants. You have any questions? I request you can unmute and ask questions. Or if you want, you can share the questions in the chat box so that I request the experts to clarify. Any questions? Participants, you have any questions? Please respond to the questions. Do you have any questions? Yeah, looks like there are no questions. Thank you, Vinay and Dr. Chandan. So before we conclude, I just wanted to invite everyone to the proposed conference, which is Lake Conference, which will be held from in the October 17th to 20th at Mudabidri. I request Vinay to share a few thoughts on Lake Conference.
Okay, hope I am audible.
Yeah, you are audible. Yes.
Yeah. So this time late will be held. This is a 14th biennial symposium that will be held at Alva's Educational Foundation. So this is the IISC's IISC and Alvas are organizing this together, where Alvas is a host for this. And so you have events and you have competitions pertaining to various aspects. It can be botanical, it can be water, it can be energy, it can be anything which talks about water, applications of water. You can use also the recent technologies such as drones or satellite image processing, or it can even be the field-based investigations, whatever you do. So it can be a holistic perspective where you generally speak out water, environment, climate, and it's not restricted. So you have n number of things in this one. You can directly go to our web page. Probably I request Bharat sir to open the last slide wherein there's a QR code. So that is easy for others to use. People who are using mobile phone can use that one to just scan it, wherein they get all the details of the symposium. So it is open for both schools, colleges of all range. It is open for teachers, it is open for students, it is open for NGOs, it is open for researchers. Everyone can do that. So with this statement, I request everyone to come to Lake Symposium, present yourself, present your thoughts on how we can conserve nature and how we can ensure sustainability in the system.
Thank, thank you, Dr. Vinay and Dr. Chandan, for sharing your valuable insights.
Thank you, sir. Thank you so much.
Thank you.
Thank you so much for sharing your valuable insights. I thank all the participants also for. Oh, sorry, there is a one question. Okay, so sorry for the delay. So there is a question on. Can you discuss about ANN techniques in land use modeling? How ANN can be used for land use analysis? I think Chandan or Vinay, one of you can respond to it.
I believe Chandan should answer this.
Yes, sir. So basically, when we speak about the urban data modeling as a whole, we have this ANN which has been tried and tested along with, as I mentioned, the classical cellular automata models. So we have something called as MLP neural network, right? So the MLP neural network can handle the inputs like DEM, slope, and if we have other layers like density, land fertility or land use, distances. So these kind of various layers can become the input for the MLP neural network. And this can be clubbed along with the classical model of cellular automata, with which we can estimate the potential transition for the very near future, maybe 2025 or 2030. And when we look at the ANN model, we have certain set of inputs that can be given. Along with that, we can also try to put a back propagation and forward feed, wherein we have a hidden layer, and ultimately we can work on it to get the output for a specific time period. So I hope I have answered the question on ANN.
Yeah, yeah, thank you. There is one question for Dr. Vinay. So you have a good appreciation also. Thank you for a very informative session. And which data was used for the classification and which classifier has been used? How the forest was separated into degraded and dense?
Okay, basically when we talk about the data, in this case, we have used higher radiometric resolution data, that is nothing but the Landsat series of data is what we had used in Landsat 8 and Landsat 9, particularly for the year 2023. We just try to take the non-cloudy data here for classification. We have used the maximum likelihood classifier, so which has also proved to be a good classifier for any analysis, something like this. So we have achieved an accuracy close to around 89%. I believe that is one of that's okay with respect to the field-based data what we have taken with regards to our previous observations wherein we had been the field. So that's where we say that we had a good accuracy there. So the next question talks about the forest degradation or forest deaths. Basically, we do something called as forest fragmentation analysis based on the pixel level distribution, how the pixels are intact, or we mean to say that whether my neighboring pixel is forest or the neighboring set of pixels are forest or something like that. Based on the pixels, we and the distribution of pixels, we try to define within a forest category whether it is interior forest is nothing but dense forest, whereas the other forest categories such as edge forest or other patch forest, we just try to take it as a degraded forest landscapes basically. So that's how we try to define a dense forest as well as a degraded forest landscape. Further, it can be still questioned wherein can we go at the species level? Definitely, it can be gone. Like it can be something like evergreen versus deciduous forest. So within those kind of scapes, we can try to further analyze. I hope that would answer the question.
Okay, thank you, Dr. Vinay, for explaining the process of separating the degraded land versus dense forest. So now I request Dr. TVR sir to share his thoughts on World Environmental Day.
Okay, thank you, Dr. Vinay and Dr. Chandan, for taking part in the very important initiative. This program is organized as a part of the World Environment Day. The current year theme is on the land restoration and the drought resilient system. That is where your work will help in identifying the region which are undergoing degradation, so that we can take it up for the restoration, so that we can revitalize the system, so that we have the climate resilient system. When we talk about climate resilient system, if we have not opted for climate resilience, then we are going to face a severe crisis of natural resources, especially the water. That is where the management of the catchment plays an important role. In that regard, the presentation by Vinay is very crucial as far as the Bangalore water is concerned. Because 55% of the water demand of the Bangalore is met by Kaveri. That also emphasizes the need for managing the Kaveri basin and identify the region which are undergoing degradation. We need to arrest that degradation by reforesting the native species. If we do it, then we will have the climate resilient system. And urbanization is another important topic when we talk about changes in climate. That is where, when we talk about urbanization, we need to have the planned urbanization. That is where this modeling and spatial decision support system will help. In that regard, the contribution or the presentation by Chandan would be useful for the planners and decision makers. Only thing is, we need to think about how to communicate this to the decision maker. We need to convey this message to the decision maker so that we have a better system with effective planning. So with this, I conclude my thanking both the speakers, as well as the Chandan and Dr. Bharat, for coordinating the session.
Thank you, sir.
Thank you so much, sir. Thank you. Thanks for sharing your insights on World Environmental Day. Now I thank all the participants for actively taking part in the discussion, and I request you to subscribe to our EWRG YouTube channel as well as WhatsApp subscription, so that you will get notified about the coming sessions. So we are going to conduct a series of e-workshops as well as webinars with respect to the environment as well as lifestyle for environment program. I request everyone to subscribe to our channel. Thank you, one and all. See you soon with another interesting topic.
Dr. Bharat,
Yes,
I am with Dr. Sumangla. She is from IHR. She is working on the vertical garden. Okay, she wants to take part in this presentations, and Tulika has shared the details with you. You can plan in consultation with her. She says that weekends are convenient, and also the time convenient to you, you can organize the program. Okay.
Sure, sir. Thank you so
So
much.
she's
I will do that.
next to me. Maybe you can see her also in the.
Sure, sir.
Yeah.
Sure, sir. I will be in touch with her, and I will ensure that we can have a one e-workshop on vertical gardens.
Yeah, sure. We can plan for that. Okay.
Sure, sir. Thank you so much.
Okay. Thank you.